Good day everyone, my name is Joyce Mitering and today I'm going to discuss polarization continuation. Polarization by reflection. Unpolarized light can be polarized either partially or completely by reflection. The amount of polarization in the reflected beam depends on the angle of incidence. Like this figure 33.27, when the light is incident on a reflecting surface at a polarized angle, the reflected light is linearly polarized. 1. If unpolarized light is incident at the polarizing angle, 2. Then the reflected light is 100% unpolarizing perpendicular to the plane of incidence. And the transmitted light is partially polarized parallel to the plane of incidence. Alternatively, if unpolarized light is incident of the reflecting surface at an angle other than PT, the reflected light is partially polarized. A Brewster's law. It is found that experimentally, when the reflected ray is perpendicular to the refracted ray, the reflected light will be completely plane polarized. The angle of incidence at which the reflected light is completely plane polarized is called polarizing angle or Brewster's angle. In the figure 33.28, the significance of the polarizing angle, the open circles represent a component of that is perpendicular to the plane of the figure, the plane of incidence, and parallel to the surface between the two materials. When the light strikes the surface at a polarizing angle, the reflected and refracted rays are perpendicular to each other tan Circular polarization occurs when the tip of the electrical field vector traverses a circle on a plane normal to the direction of propagation. A wave is circularly polarized if its consistent two perpendicular components that are equal in magnitude and plus or minus out of phase. Circularly polarized waves can also be categorized by the handedness of their rotation. The electric field of a circularly polarized waves rotates in time, and the handedness refers to whether it's rotating into a clockwise direction or in a counterclockwise direction. When viewed from the direction of propagation, by convention, renaming the wave according to the right-hand rule. To apply the right-hand rule, point the thumb of your right hand in the direction of wave propagation. If your finger curl in the direction of rotation, the wave is right-handed. If your finger curl against the direction of rotation, the wave is left-handed wave. Elliptical polarization occurs when the tip of the electric field vector traverses an ellipse on a plane normal to the direction of propagation. Elliptical polarization also involves rotation, but the two perpendicular components are either unequal in magnitude or are not perfectly plus or minus 90 degrees out of phase. The electric field vector, instead of tracing a circle, traces an ellipse. A wave is elliptical polarized if it consists of two perpendicular components that are out of phase. 2. It does not fit the criteria for linear or circular polarization. That is, the magnitude of the two perpendicular components are unequal and or the phase difference between the components is not a multiple of 90 degrees. Photoelasticity. It is a technique used in stress analysis testing based on the ability of a transparent non-crystalline materials that is isotrophic when free of stress to become optically anisotrophic, displaying the stress characteristics when stressed. Like the figure 33.31, this plastic model of an artificial hip joint was photographed between two polarizing filters, a polarizer and analyzer, with perpendicular polarizing axes. The color interference pattern reveals the direction and magnitude of stresses in the model. Engineers use the res- result to help design the metal artificial hip joint used in machine. And that is all my discussion and will be continued by my co-partners. That's all. Thank you. Bye-bye.